let's take a look at some simple properties of powers and logarithms. So let's start with something like this. If I have 3 squared times 3 to the 4th. So I have the product of two powers with the same base. We have a 3 here and a 3 here. And so if we work this all out, we'll see that we have 3 squared is just 3 times 3, and 3 to the 4th is 3 times 3 times 3 times 3. And if you go ahead and multiply this all out, 3 times 3 times 3 times 3 times 3 times 3, that's 3 multiplied by itself 6 times. And so when you multiply two powers with the same base, you add the exponents. So let's just write that as a rule. If I take any number, let me put the base x to the a times x to the b. So we have the same base here. When you multiply two powers with exactly the same base, this is just x to the a plus b. When you multiply two powers with the same base, you just add the exponents. If you divide two powers with the same base, you can probably guess that when you multiply, you add. So when you divide, x to the a divided by x to the b, that's just x to the a minus b. If I have a number and I raise it to the power 0, that just equals 1. That's true always. When you raise something to the power 0, that's always true as long as x isn't equal to 0. 0 to the 0, that's sort of like dividing by 0. We don't want to get into that right now. So if we're thinking about rules so far, we have this one, we have this one, we have this one. If I take a power and I raise it to another power, so if I take a power raised to a power, this time what you do is you multiply the exponents, x to the a times b. So when you multiply two powers, you add the exponents. When you take a power to a power, you multiply the exponents. If I have something like this, the square root of x, we can go ahead and just write that as a power also. The square root of x is the same as writing x to the power 1/2. At least we will consider them to be the same. And if someday you're taking a more advanced class and we see that they're subtly different, then we'll deal with that then. But for now, we can consider those to be the same. And if I have something like this, 1 over 2 cubed, so 2 cubed is just 8, so that's just the number 1/8. This is the same as 2 to the power minus 3. Writing something to the power minus a is the same as writing 1 over x to the power a. So we can just go ahead and have this rule. Writing x to the minus a is the same as writing 1 over x to the a. So those are the rules of exponents that I want you to remember right now. Now let's talk about logarithms briefly. Logarithms often cause people more anxiety than I think they warrant. It's really not a hard concept. So if I write log base 2 of the number 8, I'm really asking you, what power do I have to raise 2 to? This is the base. The base in this is 2. What power do you have to raise 2 to get 8? Well, so 2 to what power gives you 8? Well, I have to raise 2 to the 3rd power to get 8, because 2 times 2 times 2 is 8. So I have to multiply 2 by itself 3 times. So the log base 2 of 8 is 3. That's all there is to logarithms. That's all there ever was to logarithms. If I write log base 10 of 100, how many 10s do you have to multiply? How many times do you have to multiply 10 by itself to get 100? Well, 2, because 10 to the power 2, which is 10 times 10. So you have to multiply 10 by itself twice to get 100. So log base 10 of 100 is equal to 2. Log base 10 of 1,000 is going to be the number 3, because 10 times 10 times 10 gives you 1,000. That's all there is to logarithms. That's really all there is to it. So if, based on what we were talking about before, if I wrote log base 2 of 1/8, this is really, what power do you have to raise 2 to get 1/8? Well, we said 2 to the power -3 was the same as 1 over 2 cubed, which is 1/8. So this is just equal to -3. That's really all there is to logarithms. If you can remember the rules for powers, then we're okay for logarithms.